We'll talk about the document store, the MySQL document store in this session. So while you can read through this safe harbor statement, let me just quickly introduce myself and my colleague. So I'm Mike Sinner. I'm a senior director of software development at Oracle. I'm with MySQL since 2003, so I'm one of the old timers. I'm responsible for the clients, connectors, Workbench, MySQL Shell, the middleware, the MySQL router, and lately I've also been working on server-side features like the document store, as you can see here, and also things like Xplugin, InnoDB cluster. You might have heard we just released that 2 weeks ago. With me today is Alfredo Kojima. He's a senior manager of mine and my lead architect. And many of the things we will be discussing today have been designed by him. And he will give you an in-detailed discussion of all the things we see here, right? Dev API and all the things that make up the MySQL document store. Okay, so we'll take almost a full hour, I would say, because we have a lot of things we want to show you. I'll start with a short introduction. Then I'll explain what the MySQL document store is all about. And we will discuss scale-out, which is one of the major goals we want to achieve with the document store. And then we'll deep dive into the Dev API, which is how you use the document store, and how you can combine the document store with relational model. And then, last but not least, we will give you a live demo and you can see how to use the document store in action. Okay, so when we say document, what do we mean? So a lot of people think about just Word documents, Microsoft Word documents, when they hear document. This is a kind of special use case, but we are talking more about generic documents, structured data. And one very popular format to organize these documents is the JSON format, which stands for JavaScript Object Notation. And on the right-hand side, you can see an example. So basically, it's just structured data. Fields, values. With sublists, sub-objects, you can nicely structure your data there. So it's very generic, and most data that you have, you can squeeze into a notation like this. Yeah, so, you might also have learned about other document databases that are out there, for example, MongoDB, or also Percona has a variant of that, and there are many other document-oriented databases. They have a few things in common. So first, they are schema-less. So when you're working with MySQL, you always create a schema, you create your tables there, your views, you set up foreign key relationships, right? To have your relational model and define the schema. In document-oriented databases, there is no schema, basically, right? You just store your documents. You don't really set up any foreign keys, right? So it's much less structured. Also, you don't work with SQL, right? Because there's structured query language, but you work with no SQL APIs. That often are considered to be much easier to use. You don't need to study and learn how to use SQL just to get going with a document database, because they have very simple APIs that are based on CRUD most of the time. And scalability. This is also one very big thing, and why these document databases like MongoDB become so popular, because they promise you very good scalability. They do that by of course, introducing some drawbacks here, like all the nice stuff you get with a relational database, most likely you will not get with a current document-oriented database, like no foreign keys, no transaction support, and so on, right? So, So the question one can ask is, we have the relational database model that has proven itself over the years, over the last 30, 40 years, right? And now we have all these NoSQL, these schemaless databases, document databases. Why not combine these two together, right? And have it in one data store? And depending on your application needs, right? You either use the relational part or you use the schemaless part. And And this actually would be a very good solution for many stakeholders here, like developers, right? Schemaless design, of course, makes it easy to just prototype and just quickly get going with application. Yeah. If you would, on the other hand, have also support for transactions and stuff you're familiar with from the relational model, you have a much more powerful tool set that you can use to write your application. Same on the operations side. All the nice things that you're used to from relational databases, you will get also for the document store side. And also, of course, the business owner would be interested in finally having ACID, right? Having transactions and all these things also for their documents. So this is the goal we set, right? We want to combine both things together. And we did this in MySQL, and we are calling it the MySQL Document Store feature. So what does it do, right? What is it all about? So I think it can be summarized very easily with this sentence here. So it's an easy, straightforward way to work with JSON documents in MySQL. So working with structured data, structured documents inside MySQL. This is already available, right? We have introduced this in 5.7. So if you're coming from the SQL side, you can use the JSON data type that we added. And you can also use the JSON functions to work with the data inside the JSON fields. But the document store is much more than just this data type and the functions. Because for the document store, we introduced a lot of new things to the MySQL offering. So one thing that many people often forget, right, when they say, okay, we have now a document, we just add a JSON data type, we add some JSON functions and we're done, right? We are no SQL database. That's not exactly true, right? Because you're still missing two important parts, and that's ease of use and scalability. So what we did with the MySQL document store is we created basically a completely new way to write your database applications. So we introduced a new API to actually code against the database, and we call it the Def API, which is based on CRUD. So you can easily do things like db.products, find your find string, bind the variable, and execute and fetch all, right? So it's a very simple syntax. As you can see, it's not like SQL strings that you compose in your application and just pass through to the server, but you're really building your query here right in the language that you're writing in. That allows you to do fast prototyping, and you don't have to worry so much about the schema changes, right? Because if you store all the documents in there that have their own structure, then you can simply add new fields on the fly, and you don't need to alter table and things like that. So that's the ease of use part. But of course, most important going forward in the future will be the scale out part, because if you're writing an application today, going down the road, right, if you become really successful, the thing needs to scale, right? So using the document store will prepare you for massive scale out later on. So first, let's take a look at the scaling, and then we go back and look at the Def API in more detail, and you can see how you can actually work with the documents you store inside MySQL. So scaling is nothing really new to MySQL. We've been always scaling very well, and I think that's also part why MySQL became so successful. You can easily scale out, right? Especially on two things: vertical scaling. So you can just basically buy, if you have more access to a web page, you simply buy a bigger box to run your MySQL server to scale that way, right? And on a single box today, we can scale up to 1 million queries per second on a single machine, right? That's pretty good. And you can run multi-terabyte databases on a single box. So it's really powerful, and you can really scale well on a single machine. And if that's not good enough, you can do the read scale out, right? You add async replication slaves. You can add thousands of those, right? And really scale to massive load, like Booking.com does or Facebook does, right? They have so many users hitting the website. They have huge big replication setups managing that. All of this is available today. What's not available today out of the box is write scale out. So with traditional async replication, what you scale are the reads. But if you get a lot of writes to the system, if a lot of people insert data, or if you look at the Internet of Things, right, where you get massive of data from all the different gadgets, right, they massively insert, then you quite soon hit a bottleneck, right? Because you still have only one server, one master that you can insert, and then the inserted data needs to go down through the async slaves. So it does not scale that well. And that led to this myth that relational databases are no good for scaling your writes, right? For big data, it doesn't work. You need something different. You need NoSQL, you need big data database, you need something else. But the truth that we think is true is if you build your database using those document model principles, basically thinking NoSQL inside an SQL database, your database again will scale. So basically what you have to do is honor the principles of designing your database with the NoSQL properties. And as long as you do that, you can scale. But of course, that's not so easy, right? Because you need to know what to consider. You need to have a lot of experience writing those applications. So the big shops can do that, right? And they already have their sharding solutions in place. But if you just want a very simple interface to write a sharded application, it's not so easy today. And this is basically what changes with the document store. Because by using this new API that we have written, the Def API, if you stick to that, right? If you use that new Def API, then you can be ensured that you can then be prepared for massive write scale-out as well, and have sharding as a side effect going forward. So how are we going to do this? It's a kind of big promise that we are making, right, to deliver this write scalability, and we just cannot do it in one step because it's a huge thing that only the very big companies have been able to solve so far, and we want to put this into the hands of everybody. So the first step is the document store that we are presenting today, right? Then, of course, we want high availability. The thing must not go down. Step 3 is to add read scale-out in a very easy-to-use way, right? And step 4, then finally, is the write scale-out. And these are the steps that we are working on, and you will see them being rolled out over time. So we already presented the document store a little bit of a year ago in alpha quality, since we are still building and expanding it. We released MySQL HA, the InnoDB cluster solution, just 2 weeks ago. There have been several talks on the conference about that already. And then next we will do the read scale-out in a very easy and nice-to-do way. And then finally we will do the write scale-out. So once we have everything completed, basically this is the setup you can easily set up and maintain going forward. So you have your application nodes, you have many of those. Each application node has the MySQL router on it, and the router connects you to that InnoDB cluster you see down there. And the cluster here introduces sharding, right? You have different replica sets, shard 1, shard 2, shard 3, and the data is basically partitioned on the different shard sets depending on some sharding rules that you can define. And with a setup like this, then you can actually scale your writes, because the more writes you get, the more shard replica sets you add, the more shards you add, right? It's only limited by the amount of physical machines you can have to power this. And all this is driven by the MySQL shell to give you a very easy interface to setting all this up, because I don't know, most of you, I guess, have already a replication setup in place, and deploying a new instance is quite not so easy, right? So we are going to help with all of that. So at the end, for the developer, it will just look like this, right? So you have application nodes with your connectors. You connect to the InnoDB cluster, let the InnoDB cluster do its thing. You have the shell to manage it and Enterprise Monitor to monitor it, right? That's the goal we want to get to. So how are we actually going to pull this off? And I'm going to hand over to Alfredo, who will explain it to you.
Hello, hi. So the document store, what's the document store? So technically the document store is a layer above MySQL that works as a a document storage database. So from the point of view of the application, it's going to be talking to MySQL, and all that it does is sending JSON documents and CRUD commands to MySQL, and it gets back JSON. So you don't need to write SQL code to send to the MySQL and then translate the result set that you get back into a JSON document by using whatever client-side JSON APIs that you have. So the point where the logic of the application changes from internal data structures into JSON happens much earlier at the application side. So the document stores and returns JSON documents directly. At a more detailed level, we have these 4 basic components in the system. So the application uses the Dev API to program using connectors. Connectors encode these Dev API requests into Google protobuf messages. These protobuf messages are transported through a new network protocol that we call the X protocol to the X plugin. And the X plugin is responsible for doing the translation layer between the document store requests into SQL that can be executed by the MySQL server. So at the end, even if your application is using pure documents and using a purely NoSQL interface, all your data ends up in an InnoDB table with all the usual guarantees that you get with MySQL and InnoDB, like strong consistency, ACID compliance, and so on. So, yeah. Like I said, the Dev API is a client-side API that uses native commands, and they are translated into protobuf messages, and the X plugin does all the translation between these CRUD commands to SQL. The X protocol is a protocol that we had to introduce to perform the exchange between clients and the X plugin for encoding these CRUD command messages in a structured way. But the X protocol also does much more than just sending CRUD requests. So you can also use the X protocol for if your application just uses SQL, old school SQL, and it also adds a lot of other features into it, like asynchronous messages from the server to the client, better error handling. So if you have batches of SQL commands that you want to send to the server all at once, you can control exactly what happens if one of these commands fail in the middle. So there are lots of new features that we are adding to the X protocol itself outside of the scope of the document store, but one of the major uses that we have for it is the document store. So a little more detail into the components that are part of the document store. So the X plugin that sits in the server side and speaks the X protocol, the X protocol itself, the InnoDB cluster, which provides all these different technologies in an integrated way to give you scaling and HA for almost free and almost with no extra manual work that you have to do yourself. And we have the Dev API, which are APIs that are native to several different languages that we support. The MySQL shell, which is a front end for the interactive front end for the document store, but also is the new hub for any administrative kind of work that you want to do in MySQL. So it's like the new generation of the old MySQL command line client. And we have several new connectors that support this API. So we have connectors for JavaScript, Python, PHP, Java, C#, and C++ for now. So the Dev API, I will talk a bit about the CRUD interface for the document store, what we call the XDev API. So basically, the Dev API exposes a document-oriented database built on top of MySQL. So MySQL is there, with all its features that you have always used, but on top of that, you can treat it as a purely document-oriented database, as you would with any other document products. The Dev API, that is the interface for this document database, is, like I said, an API that allows you to write code directly in JavaScript and Python and so on. And it is based around these CRUD operations, so create, read, update, and delete, which are the basic operations that you do in any piece of data or document that you would work with in a database. So very similar to the select, insert, delete, and update commands from MySQL, but tailored and optimized for working with single documents. So by using the Dev API, what you get is that you simplify a lot of the things that you would have to do by hand using SQL when all you want, for example, is to just store documents. So if you want to work with documents, JSON documents, you really don't need to worry about columns, you don't need to worry about data types. If you want to create an index, if you would do that from SQL, it's a quite not so simple syntax that you have to use to create an index inside a JSON document. But using the Dev API, we abstract all these low-level details about the relational side, and you get all the developer sees is a document database API. But of course, you can also use the relational tables through the Dev API, including SQL if you need to for some reason. Main features. So the core concept that we are introducing with the Dev API is the concept of a collection. A collection schema object is basically behind the scenes just a table, an ODD table that has a predefined structure that can store JSON documents, of course, and has some predefined fields like an ID field, so a unique ID field that can identify every document in the collection. We have the API uses this method chaining syntax. So the syntax tries to be as natural as possible in a compiled language, while allowing things like auto-completion to work with a text editor, for example. So since all these keywords are parts of the objects that they exist in the real API, editors can probably complete them and perform validation. You can, if you are using C++ or Java, the compiler will also be able to catch several syntax errors directly in the API. We have these 4 CRUD commands. So find, add, modify, remove, that more or less match to the SQL equivalents. And we also expose a lot of the relational database features that you are probably used to. So like indexing is possible with collections in a simplified API. If you need to use transactions and row locking, that's also all available from the Dev API to work with collections and documents. And here is one snippet of code that is part of a larger REST service. So in this snippet, we have the read operation for the REST service. So HTTP GET would where you have the product and the ID as part of the REST request. In the first line, we get a reference to the products collection from the database, and using that reference object, we can call all the CRUD command methods directly from it. So product.find, we specify an expression, find expression, then there we bind the ID placeholder variable by using the document ID that we got from the request, execute it, then we get fetch the first result, and then send back that result that came directly as a JSON object back to the requester. So add, so this would be mapped to an HTTP post request. Same thing, we get a reference to the products collection. We get the data that we are adding, the JSON document that we are adding from the HTTP request. Ask it to be added to the product collection. And then finally, we send back the document ID that was generated for that document. And then delete. Very simple, get a collection reference object reference, remove with arbitrary expression, bind with ID, and just execute. So comparing the Dev API with raw SQL, so if you would want to write SQL code to work with JSON documents, it may be very natural if you know SQL very well already, and you just have to learn the additional JSON-specific features like the functions and the several syntax enhancements that we have for working with JSON documents. But still, it may be quite a lot of additional work that you have to do to get something through SQL. And at the bottom, you have the same query that we have at the top, but using the Dev API. So all the SQL related details are completely hidden, and the only thing that you see and work with in the Dev API is just specific to the document that you are working with. So the document store is not just this Dev API. So the Dev API and the document database that we built on top of MySQL is something that can be used by developers that are used to work with document database may find very familiar. But if you are if you someday need to have more structure into your database, or maybe if you already know SQL, your application already uses SQL and relational tables, but you want to add document storage to MySQL to your application, instead of looking for a separate database to store your JSON documents, you can still do that in your MySQL database using SQL, using relational tables and so on. So in this part, I want to talk a little about the SQL interface to the document store. So starting with MySQL 5.7, we have added a few JSON-related features to MySQL. We have the JSON data type, JSON functions to work with the JSON objects, a new path syntax for JSON, indexing of JSON objects, and other kinds of documents. and some SQL syntax extensions to make working with JSON through SQL a little bit easier. So the JSON data type, it is just like any other MySQL data type, but it is meant for storing, for holding JSON documents. You can use, of course, the JSON data type when creating MySQL tables. And what many people used to do before is to just store these JSON objects as blob fields or blob columns or text columns, and that works quite fine. But the problem with that is that you then cannot look inside these columns. So at the SQL layer, all this JSON data that you have is going to be completely opaque, and you can't query them. So by using the JSON data type, you get several things to work with JSON documents in a way that is more natural through SQL. So we have an internal binary format that is designed for optimizing key lookups. So if you have a big data document and need to extract the value of a field inside that document, the format optimizes for that kind of operation. Performing partial updates of these documents is also optimized by it. And you can, of course, convert to and from string values into JSON.
Are you compressing? Is the binary format compressed or is
No, it's not compressed. It's just optimized for binary lookups. JSON functions. So there is a whole new set of functions that were written for working with JSON objects, not just documents, but JSON objects and values as well. So if you need instead of storing a full document in a MySQL table, you just need to store an array of integers or strings or whatever. You can do that just fine with the JSON functionality for SQL. And to work with such values, JSON values, we have this API. So we have functions for constructing JSON values out of SQL values, like creating objects, creating arrays, querying the contents of JSON objects. So if you have a JSON object or document and you want to extract one specific field inside that, you can use these JSON functions to look inside documents and objects. We have functions like JSON contains to see if a specific value is contained inside a JSON data structure, like an array. JSON keys to list the keys of a JSON object and so on. We have functions to modify JSON values. So if you have to make a change to a JSON value so that to store the modified version back into MySQL, you can use one of these JSON functions. You can also, of course, if you are querying so you can write a JSON, a SQL query that queries a relational table that with a bunch of columns, and make the query create a JSON object directly in SQL so that you don't have to do that step at the application layer. So by combining the JSON construction functions plus the modification functions, you can do a lot of JSON operations and customize your JSON results that are sent back to the application quite easily from SQL. And in MySQL 8, we also have a few new functions, especially JSON aggregation functions. So you can create a JSON array out of several different SQL rows from, that you query from another table, for example. The JSON path syntax. So we have this JSON function that is used to extract specific fields or values from inside a JSON document, but there is also a simplified, more natural syntax for looking inside the JSON documents, which is this inline JSON path syntax. So you can use this syntax where you specify the column and then this arrow operator, and then specify the JSON path to directly reference values inside the JSON document. And the path syntax for JSON document is something described it there. So it's a syntax very close to whatever you would write in JSON, in JavaScript or Python to look inside nested objects and arrays and so on. JSON indexing. So indexing of JSON documents is done in MySQL using virtual columns. So virtual columns is another new feature that was added in MySQL 5.7. You can create a column that stores the result of a function call. So basically, you would extract a value from inside the JSON document, and you can then create an index on top of that column that you are extracting. And same thing as indexes, you can also use these virtual columns to create foreign keys. Another simple SQL example. So in this example, we are querying a relational table with a join. So the result of that query returns would normally return a record, but here we are constructing a JSON object from specific columns of the result set that we want by giving these different key names or attribute names for the object. So now I want to do a quick demo of the Dev API in the MySQL shell. Number 3. No. It used to be 3. Okay. No. Okay.
Okay, thanks.
Okay, so this is the new MySQL shell. Well, let me maybe start from the beginning.
Can everybody read this, or should we increase the font size?
It's okay?
It's okay.
So we connect to MySQL server. Let me do a bit clean up here. And in the shell, you can use 2 different scripting languages in addition to SQL. So here we have this JavaScript mode, but I'll switch to Python because I'm more familiar with Python. So the shell implements a version of the Dev API that is pretty much the same as what you would use in a connector. But since if you just want to do some quick prototyping, or if you just want to query the data to look into it or fix some problem quickly, you probably don't want to write an application or even compile some real code using a real connector just for some quick tasks. So the shell is meant to be a quick interact interface to the document store, just like the old MySQL command line client was or does for SQL. So here, when you start the shell and connect it to a database, we have a few global variables that are automatically created. So the DB object represents the schema. So we are connected to the doc store database. So DB represents the doc store. Then here I can create a collection. Actually, I think it's here. Collection called product. And also assign it to the product variable. Then from product, I will add a few documents. I don't know, some random values. And then I can, of course, query it to look at the contents. So here we see an ID field that I didn't specify myself, but it's automatically generated with a global unique identifier. And then I can write more complex queries, like look for all documents that have a price larger than that. And I want to return just the name and price and not the ID. And then execute it and fetch the first document. Oh. Oops. Yeah, this is an alpha version.
Yes, so basically this is the new version of the shell we are going to have ready for MySQL 8. So it will be the 8 version of the shell, 8.0. And we are adding some new features here like auto-completion that you don't currently have in the shell. We have this new prompt, right, that shows you some more information here and also uses some colors so you can easily see which schema you're working on, and we'll add many more things there. So this is a really, we're the first guys to see this version of the shell in production here.
So another thing that we made easy in this API is binding variables to placeholders to avoid any problems with SQL injection and so on. So if it's easier to use bind than try to hack some SQL embedding concatenation thing, then the hope is that people will do the right thing instead of trying to hack something that's dangerous and also extra work.
This is only known on the shell and not on the
Sorry?
This is only seen on the shell, only the shell.
The auto-completion, you mean? No, the whole API, the commands that I'm typing here are from the dev API, so all connectors that support it have the same features. So now I removed a product with that name, then query it back, can query it back, and so on. So the syntax for specifying the expression is very similar to the one from MySQL, but we simplified some things. So since you are just working with documents, you don't need to refer to column names or anything like that. You are always working with documents. You always refer to fields of the documents that we are manipulating. And yeah, so you have transactions too if you need to do something. I want to remove all products. What's wrong here? Yeah, so pretty much everything that you would do with a MySQL interactive client, you can do here using the Dev API. And we are also adding lots of new usability features to the show as well, like auto-completion and history, online help, and things that should make things easier for using the show.
Mm-hmm. Okay, so just the takeaways from the presentation. We're looking at a new modern way to write your MySQL applications using a new Dev API, making it very easy also for people who are not so familiar with SQL to write applications, but also for more experienced guys to combine relational with non-relational data and just bring them together. And I think one of the most important things is that if you write your applications using this new Dev API, then it will be future-proof because you can then expect your application to also scale your writes. We are doing a lot of blogging about the document store, so if you're interested, then please just visit our blog there and read the latest about the document store. And of course, it's still in alpha quality, we're still working on it, but we are really, really pushing to be able to give you a GA version soon. So please stay tuned. Okay, thank you. Yeah. Okay, so any questions on the stuff we just presented and you saw?
One small thing that is it possible to join, obviously with SQL in the back end, you can join tables and collections together. Is that something that you hope to support through the Dev API interface?
Mm-hmm. So the question was, you have your collections stored in documents and you have your relational tables. What happens if you want to bring those together and join them? So we are working on a join feature for the Dev API. We are not calling it joins, right, because that's from the relational world, but we are calling it links. So basically what you can do, you can set up links between collection fields and link over to fields from a relational table. So this will be coming, and it will allow you to do things like nest results. You want to explain it?
Yeah, so you can, so if you have a join with a group by, for example, you can nest the grouped together items into a subarray from the document that you're extracting. So we have many of these features that allow you to transform relational data into JSON data, and also the other way around. If you have JSON data, you want to query it like a SQL query by filtering each item from a JSON array, for example. There are going to be features that should do that.
Mm-hmm.
One thing we forgot in the presentation was to point out the fact that the CRUD API works on tables and just collections. So
Yes.
it actually makes it easier to write table-based things as well.
Right, so we have been showing the Dev API just on collections, but as you saw, these CRUD operations, they are also available for relational tables. So you can also use a stripped-down SQL right through the Dev API. And if you do it that way, you can also be ensured that if you use the Dev API, you can later on be prepared for the sharding. And that's also will be the part where the linking feature comes in. Mm-hmm. Very good question.
When we create a collection, so in that case, is it a table which gets created in the database itself with a field of JSON type and an ID field? So there are those two fields that a table gets created with just those two fields.
Mm-hmm. So the question was, how does a collection actually look like in the database? Because Alfredo explained it's actually a virtual table, right? It's a table. So what's the structure of the table? How does it look like? Alfredo, maybe you can just show how a table looks like. Basically, you're correct, right? So it has one field for the actual document called doc, and it has one virtual column _ID, which extracts the _ID from the JSON document as a virtual column, so we can easily index that. So, right, so he will just show the structure of the table. So you have the JSON column here holding the document, and you have this virtual column here of the ID that already looks inside the document to give you the underscore ID. So we can index that and use it as a primary key. So yeah, your assumption was correct. So basically, it's a standard table, but if a table has that format, we treat it like a collection object. Mm-hmm. Okay, good questions coming. Any more questions you guys can think of? Yes.
One document can have, let's say, 5 fields and the values, and
Yes.
another document can have just 2 fields. So what happens to that index? If you create an index on a column in that JSON document, which is not present in the other JSON document, so how does that?
So for that case, you would create 5 indexes for all the indexes that you want, but the values, the documents that are missing some key are just going to map to a null value. So your indexes are going to have null values for all the documents that don't have some specific field.
Right, so, and you can also turn it around. So if you want to ensure that your document always has this field, right, you create an index that has not null. And if you then try to insert in a document that does not have that field set, right, the insert will fail.
We can add some SQL or MySQL constraints into your JSON data. So, for example, if you want a unique index inside of a value inside a JSON document, you can create a unique index on the extracted value. So you can have SQL like schema enforcement or structure enforcement of your JSON documents, just like you would in relational tables.
Right, so all the benefits you know from the relational world, you can also apply with the virtual columns into the document itself. So it's really powerful. Okay, no more questions for today. So thanks a lot for listening to the end. Thanks.